Okay, today, day number 7, probability and statistics, binomial distribution. Here's what binomial means. Success or failure, right? So flipping a coin, rolling a die, rains or doesn't rain, right? That's binomial distributions. So the thing we do need to know is we need to know n, the number of trials. We need to know p, which is the probability of success. I can spell. We then can find q, which is the probability of failure. And then we need to know x, and x is the number of I guess we could say successes. And successes can be built either off of P or off of Q, depending on what we're calling a success. Okay. Okay. So what we're going to do is we're going to find mean and variance. Mean is just expected value. Variance is going to be related to expected value. So let's get started. A refrigerator has 9 small yogurts. 4 of them have expired. A customer makes a random purchase of 3 yogurts. The random variable x denotes, this is important, x will denote the number of expired yogurts. Well, we're going to find out the probability that they do. Fill in the distribution and calculate the expected value. So why don't we go partner group work here? Find the probabilities of 0, 1, 2, 3. Okay. Should we do one of them together and do the rest separately? Okay. So let's talk P and Q. In this case, we're going to, even though it's not a success, we're going to call P, well, actually, this isn't a true binomial. Why isn't this a true binomial? I'm going to answer my own question on that. Because each time, what happens to the probability? It changes. So in a true binomial, the probability won't change from trial to trial. Okay, so let's talk about getting 0 expired yogurts. Probability of x equaling 0. Okay, so I'm selecting how many of them? 3. Okay, so probability of getting 0 of them. So that means I get a non-expired or still good yogurt 3 times in a row. So what would that be? That'd be 5 out of 9. Then what? 4 out of 8. 3 out of 7. Okay, let's figure out what that is. Let's do some reducing if we can. That's 1/2. That's 1/3. Maybe I shouldn't have done that, but we'll see. 5 out of 42. What would that have been if I didn't reduce? 20, 60, 60 out of... Oh, gross. What's 9 times 8 times 7? 504. Okay, let's see. Uh-oh. Uh-oh. Oh, my answer's wrong. Why? Why is my answer wrong? Because I assumed they were replaced. Let's not do that. Let's go with our answer. 60 over 504. My answer is going to be wrong here and on the next slide, but that's okay. Will you, with a neighbor, talk through 1 and 2 and 3? 60 over 504. Okay, so we found our probability that x equaled 1 to be 240 504ths. Probability x equaled 2 to be 180 504ths. And the probability x equaled 3. I got reservations. Is it going to be 504? Is it? Okay. All right. It worked out. I'm glad it did to be 24 504ths. So these 4 items, 60, 240, 180, and 24, should add up to 1, and they do. What would be the mode here? Mode is what? Most often, right? So which of these has the greatest probability? X equals 1. Most often, you're going to get one expired yogurt. What would be the probability that we would get at least one expired yogurt? Well, it'd be 504 minus 60 over 504. Right? That'd be the probability of X equals 1, 2, 3, and, well, 1, 2, and 3 added up. Right? The expected value, it's not going to be right here, but what we would do is we'd take, like we did yesterday, 0 times 60 504ths plus 1 times 240 plus 2 times 180 plus 3 times 24. That would be our expected value. Let's do a quick calculation on that and see what it is. 0 60s is 0. 1 240 is 240. 2 180s is 360. 3 24s is 72. 504ths. So add those up, we get 500, 672. Hey, look at that. We would expect a little over one expired yogurt per, right? And that expands out to multiple trials, depending on how far out we want to go. But that's on average what we'd expect for X. Recall that the expected value is the same as the mean, mu. Right, the mu of that distribution. Okay, so far so good. All right, let's keep rolling. Okay, so what we're going to do here is we're going to use what we had just had. 60, what was it, 240, 180, and 24. What we're going to do is I'm going to show you how to find the variance and the standard deviation of this thing. And it's not that bad. It's just a little bit of calculator work. Okay, so expected value we already found. So expected value we said was, what was it, 600 and what? 672 504ths. The variance of the distribution will be e to the x squared, the expected value of x squared. I'll talk about that in a moment, minus this 672 over 504 squared. So let's talk about e to the e of, or expected value of x squared. Here's what we do for expected value of x squared. It's just a quick manipulation. All I do is I square this number. And then I take that number times our probability to get the expected value of x squared. Make sense? So let's do that relatively quickly. Somebody have a calculator available. Let's find the expected value of x squared. 0 squared is 0. 0 times 60 over 504 is 0. 1 squared is 1 times 240 over 504 will be 240 over 504. 4 times 180 is 720, I think. Yep, 720 over 504 is that. And then 9 times 24 is 180, 216. Good. 216 over 504. Victor, will you add those numbers up? Just the numerator. Okay, and then I'm going to subtract the expected value of x squared. Victor, what'd you get? 1176 over 504. Okay, could you multiply 1176 times 504? Almost. Yeah, go ahead. Okay, 592,000. And what's 504 squared? Okay. Victor, 672 squared. Okay, so here I have, before I go any further, this is the expected value of x squared minus the expected value of x quantity squared. The reason that I multiplied this and this by 504 was to get a common denominator. And now I can combine them to get the variance. So, yep. Victor, 592,704 minus 451,584, if you would. 141120 over 254,016. This is going to be the variance of x. That is the variance of x. How would I find the standard deviation of x? Excuse me. Yeah, variance of x. How would I find the standard deviation of x? Remember, variance is sigma squared. Standard deviation is sigma. Square root of that. Two ones in there. Okay, and I'm going to leave it at that. I think the rest of that is a basic calculation that you should be able to do. I have now found the variance and the standard deviation. Okay, so when you see a true binomial function, it's so much easier, you guys, to find the variance standard deviation. Instead of doing all that garbage, guess what? The expected value for a binomial, and it's not on this slide, but for binomial only, expected value is number of trials times success probability. That's it. If it's truly a binomial, meaning that the probability doesn't change each time. Okay, and then variance, you're going to like this even better. Variance, instead of doing all that garbage, if it's binomial, would be n times p times q. It's that easy. What? Did you say that's cute? Q is probability of failure. P and Q always add to 1. Thank you for leading me into that. It was almost as if I did that on purpose, but I didn't. Okay. So P is the probability of success, Q is the probability of failure, and P plus Q equals 1. N is the number of trials. Okay. Now, this right here should maybe hurt your head a little bit, but let's take it and apply it to an example. A die is rolled 6 times. What's the probability of rolling 4 exactly 3 times? Okay, I'm going to show you the difficult way to do this, and then I'm going to show you the, well, why didn't you show me that first method? Okay, the random variable x will denote the number of 4s rolled. The number of 4s rolled. Okay, so let's think about this for a moment. What is this notation right here? What does that mean? N choose x, right? So you know how in previous slides we've been multiplying by 3? Right? That was 3 choose 1 or 3 choose 2. That's why we multiplied it by 3 on that previous example. So here, if I want to know the probability that x equals 3, right? I'm going to say x equals 3. I don't want x equals 4 because it's not the number of times I want that thing to come up. The number of times I want x to come up or 4 to come up is 3 times. So I would take 6, choose 3. If you like this notation better, you can use that. No problem with that. Times the probability of success. What's the probability that I roll a 4? 1/6. So that's P. P is 1/6. What's Q? Yeah, 5/6. So it'd be P. I want to roll that 3 times. I want to roll the 4 3 times. How many times do I want to fail then? Yeah, 6 minus 3, which would also be 3. So I'm going to have 6 choose 3, which is 6 factorial over 3 factorial, right? This one right here is n, or excuse me, yeah, n minus x, and the other is x. So this should be n minus x factorial. This would be x factorial. Okay, so 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. I could lop off the 3, 2, 1, so that'd be 6 times 5 times 4. But then I want to divide that by 6, because it's 3 times 2 times 1. So that would be 20. Is that 20? Okay, so 6 choose 3 should be 20. Oh, this is so much work. Isn't there a better way? Yeah. And then 1/6 to the third power, well, that's 1 over 216. That's going to get gross. And 5/6 to the third power is 125 over 216. That's going to get gross. I'm going to get some decimal for this, but I'd rather use my calculator. How about you? Yeah, okay. So take out your calculator. And what I'd like you to press is, and I don't have my calculator, that's cool. Okay, let's see here. I want you to press second vars. Second vars. And I want you to find binomial, binom PDF. Binom PDF. The PDF is going to find the probability of one possible value, x equal to 3 in this case. So the first thing I want to do is put in the number of trials. So this should be n. Then I want p, the probability of success, and then I want x, the number of successes. So you should have a, what is that, 1/6? And then you should have, what is x? 3. What do we get? Somebody got it? 0.053? 0.054? Okay. Come on now. Eraser, engage. There we go. 0.054. Okay, now I'm going to do this just to prove it. 20 times 1 over 216 times 125 over 216. Ooh. What's 216 times 216, please, somebody? 46,656, like that. Okay, and then 20 times 125 is 2,500. Somebody take 2,500 divided by 46,656. 0.054. Good. Shortcut. Hello, that's your friend. Okay, let's talk about the other application of this in a moment here. You have 3 friends, don't you? That's pretty good. I only have 4, and I'm related to 2 of them. Okay, this thing right here is powerful. Binomial PDF NPR, or in our case, we used X, right? That's powerful. It can find you the probability, if it's a true binomial, of just one possible scenario. Like, I want a 4 3 times. But what if I said I want a 4 at least 3 times? At least 3 times. Then I use CDF. So let me explain. If you did this, binomial CDF, let's say 6, I'm going to go 1/6, and I don't know, let's put a 2 here. This would calculate for you this probability from 0 up until 2. It would calculate that probability for you. That's CDF. So if I wanted this, let's say I wanted the probability, I'm just going to say forget that question there. If I wanted the probability that I rolled x greater than or equal to 3, then in my calculator, I would take, let's go here. Probability is 0, 1, 2, 3, 4. How many times did I roll in that dice? 6 times, okay. I want these, right? I want the probability of those all added up. Someone's going to do binomial PDF 4 times because they're going to go, how do I use CDF? CDF is your friend. What's true about these 7 probabilities? What do they have to add to? They have to add up to 1, right? The probability of all of those has to add up to 1. So how could I find the probability of x greater than or equal to 3? It'd be 1 minus binomial CDF 6, 1/6, 2. All right, if I took 1 minus the probability up to including 2, that would leave me the probability after 2. Right? So it's kind of a cool concept. You can use that to your advantage. Austin, let's do one of these maybe on the homework if we can find one. Okay, and then I want to do one more thing after that. Okay, during an election campaign, 66% of population of voters are in favor of food quality control. Only 66%. What? A sample of 7 voters was chosen at random from this population. Probability there will be 4 voters that were in favor. Exactly 4. So that tells me PDF. All right, probability that x equals 4 would equal binomial PDF. How many are there? 7 voters. What's the probability that they were in favor? 0.66. And exactly 4. That's how I would do it. Plug it right in, done. Okay, in the second part it said there are at least 2 voters who were in favor. At least 2. That means we don't care about 0, 1. So how would we find the probability that x is greater than or equal to 2? 1 minus binom CDF, right? Accumulation. 7.66, and what number goes there? 1. Don't put 2 in there, it'll include the 2. We want 2 in the final probability. Okay. All right. Okay, the last thing I want to do is just cover, like I had said earlier, the expected value when dealing with binomial is just NP, and the variance is NPQ. Okay, the standard deviation, if it's binomial, would be the square root of NPQ. So I want to show you how that applies to this slide right here. You know very little information here, but you have enough to find out the probability that x equals 3. Okay, what do I know about the expected value? Well, expected value equals n times p. Well, I know that n times p equals 8. The variance, if it's binomial, is NPQ. I'm told the variance is 4.8. I have enough information because I know what NP is. What is that? 8. So I know 8 times Q, probability of failure, equals 4.8. If I divide both sides by 8, oh boy. Q equals 48 over 80 is 0.6. Somebody confirm. Okay, good. So I know Q is 0.6. What would P equal? 0.4. They got to add to 1. What does N equal? Well, I can figure that out. I know P equals 0.4. I don't know N, but I do know 0.4 of the number of trials equals 8. If I divide, I think 40% of what is 8, that's 20. So I know the number of trials. I know the probability of success. I could use my long formula using combination, or I could just be smart about it and use my calculator. Let's go binomial. Is it PDF or CDF? PDF, why? Yeah, it's x equals 3. So the probability that x equals 3 would be binomial PDF. We had 20 trials. Probability of success was 0.4. And we want to know x equals 3. Someone calculate. 0.012. Is that good? Typically 3 decimals is the way to go. Somebody else confirm or deny? Confirm? Good. The only mode you have to be in on your calculator is function mode. I don't care if you're in degrees or radians, that's not a big deal, but function mode is necessary for this to work. Okay, binomial PDF, CDF. Tomorrow we're going to cover, I think it's Poisson, PDF, CDF. And then it's going to be normal PDF, CDF. So your friend, PDF, CDF, you should like them. They help you out big time. Okay, that's it for today. I'm going to try not to delete this video.